March 15th, 1944, Anzio Beachhead, Italy, EO 6:30 hours. The morning mist clung to the muddy crater field like cigarette smoke in a closed room. Staff Sergeant Thomas Mackenzie crouched behind the twisted remains of an American Sherman tank, its turret blown clean off 3 days prior. Around him stretched what the men called the Iron Graveyard, a quarter-mile stretch of no-man's land littered with the burned hulks of Allied armor. Mackenzie wasn't infantry. The grease-stained coveralls and the worn toolbox at his side marked him as what he was, a mechanical engineer from Detroit who'd been drafted into the Army Corps of Engineers. Back home, he'd spent 12 years designing transmission systems for Chrysler. Here in Italy, he crawled through battlefield wreckage, trying to understand why American tanks kept dying. The sound reached him first, a deep mechanical growling that seemed to rise from the earth itself. Mackenzie pressed his face against the cold steel of the Sherman's hull and peered through a jagged hole in the armor. 800 yards away, a German Tiger I was reversing into a hull-down position behind a stone farmhouse. 56 tons of German engineering, an 88 Mittelbe gun that could punch through Allied armor at ranges that made return fire impossible. Mackenzie had seen the mathematics of destruction firsthand. Shermans required 4 direct hits to disable a Tiger, while a single Tiger round could eliminate any Allied tank on the battlefield. The Tiger's transmission whined as the massive tank adjusted its position. Even at this distance, Mackenzie could hear the precision of German mechanical engineering. No grinding gears, no missed shifts. The Maybach HL230 engine and its 8-speed transmission operated with the reliability of a factory machine. Mackenzie opened his field notebook and sketched the Tiger's silhouette, adding technical annotations in the margins. Frontal armor, 100 mm. Side armor, 80 mm. Weight distribution, forward heavy due to thick frontal protection, and most importantly, the drivetrain configuration that made it all possible. A mortar round impacted 50 yards to his left, showering him with dirt and shrapnel. Mackenzie didn't flinch. He'd grown accustomed to working under fire. What troubled him wasn't the immediate danger. It was the systematic nature of Allied losses. Every engagement followed the same pattern. Tiger tanks would establish overwatch positions, engage Allied armor at maximum range, and withdraw before effective return fire could be delivered. The American tank crews weren't cowards. They were outmatched by superior engineering. Mackenzie closed his notebook and began the dangerous crawl back to Allied lines. Behind him, the Tiger's engine note changed pitch as it maneuvered to a new firing position. Another hunt was beginning. Another group of American tank crews would roll forward in their Shermans, confident in their training and courage, only to discover that war was ultimately decided by metallurgy and mechanical advantage. As he slipped through a drainage culvert that led back to the American positions, Mackenzie's mind was already working on the problem. Detroit had taught him that every machine had weaknesses, every transmission had breaking points. Every gear train could be compromised if you understood the stress patterns and failure modes. The Germans had built a superior tank, but they'd also created a machine dependent on precise mechanical tolerances and specific maintenance procedures. Mackenzie had spent 3 months studying captured Tiger components, and he was beginning to understand something the German engineers might have overlooked. Their greatest strength could become their greatest vulnerability. The briefing tent reeked of coffee grounds and wet canvas. Major Harrison stood before a tactical map of the Anzio sector, red pins marking locations where Allied armor had been destroyed over the past month. The pattern was unmistakable, a semicircle of engagement zones where Tiger tanks had established killing fields. 17 Shermans lost in 2 weeks, Harrison announced to the assembled tank commanders. Average engagement range, far 200 meters. Average time to Allied tank destruction, 43 seconds from first Tiger muzzle flash. Mackenzie sat in the back of the tent, officially present as a technical observer, unofficially gathering data for his own investigation. He watched the faces of the tank crews as Harrison continued the briefing. These were experienced soldiers who'd fought their way up the Italian peninsula, but the mathematics of Tiger engagements were wearing them down. Lieutenant Colonel James Mitchell, commander of the 752nd Tank Battalion, raised his hand. "Sir, we've tried everything. Flanking maneuvers, smoke screens, concentrated fire missions. The Tigers withdraw before we can close to effective range." Harrison nodded grimly. "Intelligence reports suggest the Germans have positioned 6 Tiger tanks around Anzio. 6 tanks are controlling 12 square miles of battlefield." Mackenzie had examined the destroyed Shermans extensively. The German 88mm rounds didn't just penetrate Allied armor, they created catastrophic failures that left the tanks unrepairable. Meanwhile, when Allied rounds did hit Tiger tanks at extreme range, they typically bounced off without causing significant damage. After the briefing, Mackenzie approached Lieutenant Ross Weber, a Sherman commander who'd survived 3 Tiger encounters. Weber's tank bore scorch marks where German rounds had deflected off the turret at oblique angles. "Tell me about the transmission sounds," Mackenzie said without preamble. Weber looked puzzled. "What do you mean? When the Tigers maneuver, what do you hear?" Weber considered the question seriously. Tank crews developed acute hearing for mechanical sounds. It could mean the difference between identifying enemy armor and friendly vehicles. "Smooth gear changes," Weber finally answered. "No grinding or hunting. The transmission sounds precise, like it was engineered by watchmakers." Mackenzie nodded. He'd heard the same thing during his observation missions. German transmissions operated with mechanical tolerances that American manufacturers couldn't match with mass production techniques. The Maybach transmission represented thousands of hours of precision machining and hand-fitting. That evening, Mackenzie spread captured German technical manuals across his workbench. The documents, obtained through various intelligence channels, contained detailed maintenance procedures for Tiger tanks. What he found confirmed his growing suspicions. The German transmission required specific lubricants, precise adjustment procedures, and regular maintenance intervals. The 8-speed gearbox used synchronized shifting mechanisms that demanded exact clearances between gear teeth. Any deviation from specifications could cause catastrophic drivetrain failure. More importantly, the Tiger's weight distribution created enormous stress loads on the transmission during maneuvering. The German engineers had compensated for this by using hardened steel components and precise manufacturing tolerances. But they'd also created a system with no margin for error. Mackenzie pulled out his notebook and began calculating stress loads and failure modes. The Tiger's transmission was simultaneously its greatest asset and its most vulnerable component. If the precise tolerances could be disrupted, the entire drivetrain would destroy itself under operational loads. The question was how to introduce that disruption without direct access to German vehicles. Mackenzie worked through the night, sketching mechanical diagrams and running calculations. Outside the tent, artillery fire rumbled across the Italian countryside. By dawn, he'd filled 17 pages with technical analysis and preliminary design concepts. The solution wouldn't involve building a better tank. It would involve making the German tanks destroy themselves. Mackenzie's workshop occupied a corner of a bombed-out farmhouse 3 miles behind the front lines. Officially, he was conducting technical analysis of captured enemy equipment. Unofficially, he was designing something that existed nowhere in Allied doctrine or German nightmares. The components spread across his workbench looked innocent enough. Steel washers scavenged from destroyed vehicles, ball bearings from aircraft engines, springs from tank suspension systems, wire salvaged from communication equipment. To any observer, it appeared to be the usual collection of battlefield debris that engineers accumulated. Mackenzie held up a steel washer, examining its thickness with calipers. precisely 2.3 millimeters, thin enough to slip between gear teeth without immediate detection, thick enough to create catastrophic misalignment under load. He'd calculated the dimensions based on captured German transmission specifications, working backward from failure modes to determine optimal sabotage configurations. The device he was constructing defied conventional military logic. Standard sabotage targeted obvious vulnerabilities: fuel systems, ammunition storage, control mechanisms. Mackenzie's approach was more subtle. He intended to introduce microscopic mechanical irregularities that would amplify under operational stress until the German tanks destroyed themselves. Corporal Danny Morrison, Mackenzie's unofficial assistant, watched from across the workbench. Morrison had worked in a Chicago machine shop before the war and possessed the practical skills needed to fabricate precision components under battlefield conditions. "I still don't understand how this works," Morrison admitted, carefully filing notches into a steel disc. Mackenzie picked up a gear assembly from a destroyed Sherman transmission. "Watch the teeth engagement," he instructed, rotating the gears slowly by hand. Perfect mesh, no binding, no irregularities. He inserted one of his modified washers between the gear faces and rotated the assembly again. This time, a slight grinding sound emerged as the gear teeth struggled to accommodate the foreign material. "Now imagine that under 56 tons of operational load," Mackenzie continued, "the transmission tries to compensate for the irregularity. Gear teeth develop stress fractures. Synchronizers lose timing. Eventually, the entire drivetrain experiences cascading failure." Morrison nodded slowly. "But how do we get these things inside German tanks?" Mackenzie had been working on that problem for weeks. Direct sabotage was impossible. Tiger tanks were heavily guarded and maintained by experienced German mechanics. But he'd studied German maintenance procedures extensively and identified a vulnerability in their logistics chain. German tanks in Italy depended on replacement parts shipped from manufacturing facilities in Germany. The parts traveled through a complex supply network involving rail transport, truck convoys, and forward depots. Somewhere in that chain, there was an opportunity to introduce modified components. Mackenzie opened a captured German parts catalog and pointed to a specific item: transmission synchronizer rings, part number 4736B, replaced during standard maintenance every 200 operating hours. He held up one of his modified devices, a steel ring that appeared identical to the German original except for microscopic alterations in the gear tooth interfaces. "The Germans receive replacement parts in sealed containers," Mackenzie explained. "They don't inspect individual components. They trust their supply chain. If we can introduce modified parts into their logistics network, German mechanics will install them during routine maintenance." The plan sounded impossible. It required infiltrating German supply lines, substituting modified parts for genuine components, and ensuring the sabotage remained undetected long enough for operational failure to occur. Any single point of failure would compromise the entire operation. But Mackenzie had spent 3 months watching Allied tanks burn under German fire. Impossible plans were preferable to certain defeat. Morrison examined one of the modified synchronizer rings under a magnifying glass. The alterations were invisible to casual inspection. Stress concentration points machined into gear teeth, bearing surfaces altered by fractions of millimeters, oil passages slightly constricted to reduce lubrication flow. "How many tanks could this affect?" Morrison asked. Mackenzie consulted his notes. "German doctrine requires major maintenance every 600 operational hours. If we can introduce modified parts into their supply chain, every Tiger tank in Italy will eventually install compromised components." The timeline was months, not days, but the results would be devastating. German tank crews would experience mysterious mechanical failures during critical engagements. Transmissions would seize during combat maneuvers. Gear trains would disintegrate under operational loads, and the German engineers would never understand why their precision machinery was destroying itself. April 3rd, 1944. Highway 7, north of Anzio, 13:47 hours. The German supply convoy consisted of 4 trucks carrying replacement parts for armor units in the Anzio sector. Mackenzie crouched in a roadside ditch, watching through binoculars as the vehicles approached the prepared ambush site. Office of Strategic Services operatives had spent 2 weeks planning this interdiction, not to destroy the convoy, but to substitute modified components for genuine German parts. Mackenzie's pulse quickened as he spotted the 3rd truck, identified through intelligence reports as carrying transmission components. Inside his pack were 12 modified synchronizer rings, each one indistinguishable from German originals, except for the microscopic alterations that would eventually cause catastrophic failure. The ambush unfolded with practiced precision. OSS agents disabled the escort vehicles with small charges that simulated roadside bomb attacks. German guards scattered into defensive positions, exactly as predicted. In the resulting confusion, Mackenzie and 2 specialists slipped toward the supply truck. The truck's cargo bay contained wooden crates marked with German technical specifications. Mackenzie located the transmission parts container and worked quickly to remove the original synchronizer rings. His hands moved with mechanical precision, substituting modified components for genuine parts while maintaining the original packaging seals. 17 minutes after the initial attack, the OSS team withdrew, leaving the Germans to believe they'd survived a failed ambush attempt. The convoy resumed movement toward German positions, carrying 12 time bombs disguised as precision machinery. 2 weeks later, Mackenzie received the first confirmation of success. Lieutenant Weber approached him during evening maintenance, his expression puzzled. "Something strange happened during today's engagement," Weber reported. "That Tiger that's been controlling the crossroads near Monte Battaglia, it started making weird transmission sounds during the firefight." Mackenzie kept his expression neutral. "What kind of sounds?" "Grinding gears, like the synchronizers were binding. The tank withdrew after 5 minutes of engagement instead of the usual 30. Mackenzie nodded casually, but internally his excitement was building. The modified parts were beginning to affect German operations. The Tiger crew had probably noticed minor transmission irregularities and withdrawn for mechanical inspection. Over the following days, additional reports filtered back from frontline units. German tank activity was decreasing in several sectors. Reconnaissance flights reported Tiger tanks remaining in static positions instead of conducting the mobile operations that had characterized German tactics. On April 18th, Mackenzie received confirmation of the first catastrophic failure. Major Harrison called him to the intelligence tent, where aerial reconnaissance photographs covered the situation table. The images showed a Tiger tank immobilized in an open field, its crew standing nearby examining the drivetrain. "Photo interpreters say the transmission casing is cracked," Harrison explained. "No evidence of external damage. The tank appears to have suffered mechanical failure during maneuvers." Mackenzie studied the photographs carefully. The Tiger's hull was intact, but dark stains around the transmission housing indicated catastrophic lubrication loss. His modified synchronizer rings had introduced stress concentrations that caused the transmission casing to fracture under operational loads. But the real test came 3 days later during a major German counterattack. The German assault began at dawn with artillery preparation followed by armor advances. Intelligence had identified 4 Tiger tanks participating in the operation, supported by Panzer IV medium tanks and infantry units. Mackenzie positioned himself with a forward observation team, ostensibly to gather technical intelligence, but actually to witness the results of his sabotage campaign. Through field glasses, he watched German armor advance across the open ground between Monte Battaglia and Allied positions. The first Tiger suffered transmission failure 400 meters into the advance. The massive tank rolled to a stop, smoke rising from its engine compartment as the crew attempted emergency repairs. The second Tiger lasted longer, reaching within 200 meters of Allied lines before its drivetrain disintegrated with an audible crack that carried across the battlefield. 2 of the 4 German heavy tanks had been eliminated without a single Allied shot being fired. The remaining German forces continued the attack, but without heavy tank support, they were driven back by defensive fire. What should have been a breakthrough operation became a costly failure that consumed German reserves without achieving tactical objectives. That evening, Mackenzie sat in his workshop, listening to artillery fire in the distance. His notebook contained detailed observations of transmission failure modes and their tactical implications. The modified synchronizer rings were exceeding performance expectations. German tank crews were beginning to distrust their own machinery. May 1944. Allied Intelligence Headquarters, Naples, Italy. The briefing room fell silent as Colonel Matthews finished reading the casualty statistics. German tank losses in the Anzio sector had increased by 340% over the past month, but Allied forces had fired 60% fewer anti-tank rounds. The mathematics defied conventional warfare analysis. Mackenzie sat at the back of the room, officially present as a technical consultant, actually listening to confirmation of his sabotage campaign's success. The modified synchronizer rings had spread through German maintenance channels like a mechanical plague, causing transmission failures across multiple armored units. Intelligence suggests the Germans are experiencing unprecedented mechanical reliability issues, Matthews continued. The Tiger tank operational availability has dropped to 31% of authorized strength. Their mechanics can't identify the source of the failures. Mackenzie had monitored German radio communications through signals intelligence channels. German tank crews were reporting mysterious transmission problems during combat operations. Mechanics performed complete drivetrain overhauls, only to experience identical failures within days of returning to service. The Germans suspected sabotage, but couldn't locate the source. They'd implemented additional security measures around maintenance facilities, conducted extensive inspections of replacement parts, and even replaced entire maintenance crews. But the failures continued because the sabotage was embedded in their supply chain, hidden within components that appeared completely authentic. Lieutenant Colonel Mitchell raised his hand. "Sir, what's our assessment of German countermeasures?" Matthews consulted his intelligence summary. German engineers are conducting complete transmission redesigns. They're also implementing new maintenance procedures and expanding quality control inspections. However, their current operational capabilities remain severely compromised. Mackenzie smiled slightly. The German response confirmed that his sabotage had achieved strategic impact. German engineering teams were wasting resources pursuing solutions to problems they couldn't properly diagnose. Meanwhile, Tiger tanks remained sidelined for mysterious mechanical failures. After the briefing, Mackenzie returned to his workshop for the final time. Allied forces were preparing for major offensive operations, and his technical analysis mission was concluding. But his real work, the systematic destruction of German armor through mechanical sabotage, had already succeeded beyond any reasonable expectation. Morrison helped him pack the remaining tools and components. "Think the Germans will figure it out?" Morrison asked. Mackenzie considered the question seriously. "Eventually, but not in time to matter." He picked up one of the original modified synchronizer rings, examining the microscopic alterations that had caused millions of dollars in German equipment losses. The device represented months of technical analysis, precision manufacturing, and dangerous infiltration operations. But it also demonstrated something more fundamental about the nature of warfare. Victory didn't always belong to the side with superior equipment or tactics. Sometimes it belonged to the side that better understood the enemy's dependence on mechanical precision and supply chain reliability. 3 weeks later, Allied forces launched Operation Diadem, the offensive that finally broke German resistance around Anzio. German armor response was limited and uncoordinated. Tiger tanks that should have anchored defensive positions remained in maintenance depots, their transmissions destroyed by components they'd installed themselves. The official after-action reports credited Allied numerical superiority and tactical innovation for the breakthrough. Mackenzie's sabotage campaign remained classified, buried in intelligence archives where it would stay for decades. But in Detroit machine shops and engineering classrooms, quiet legends began circulating about an army sergeant who defeated German armor with nothing more than precise measurements and an understanding of gear-tooth stress patterns. The stories were never confirmed, never officially acknowledged. They didn't need to be. The silence itself was proof of success, the kind of victory that left no witnesses, no evidence, no recognition, just empty German tank parks and the gentle sound of precision machinery destroying itself, one gear tooth at a time. In his final report, Mackenzie wrote, "Target mechanical reliability compromised through supply chain integration of modified components. Enemy operational capability reduced by systematic drivetrain failure. Recommend expansion of program to additional theaters of operation." The words were calm, factual, and haunting. Somewhere in the Italian countryside, German tank crews were still trying to understand why their machines had betrayed them. They would never know that the answer lay in the microscopic precision of American sabotage, engineered by a sergeant from Detroit who understood that the most devastating weapons were often the ones the enemy never saw coming.